Hi everyone, I hope you guys are all doing well. My name's Tris,
My name is Colvir.
and we're from a club at UCLA called Interaxon. And today we're going to be talking with you guys a little bit about something called brain-computer interfaces. So we'll just go ahead and get straight into it right now. And I'll start right off the bat with this little Baby Yoda gif and ask you guys if any of you think that it's possible to move an object without touching it at all, but by simply just thinking about moving it. Which I know sounds like a ridiculous question, kind of like something straight out of a sci-fi movie, but through the works of both neuroscience and technology, this can actually be done. So let me ask you guys another question for you to actually pause the video this time and discuss for a minute. And that question is, what is artificial intelligence? So if any of you have an idea from something you've maybe heard about or read about or seen in a movie or something, you can go ahead and share what you know about it. So artificial intelligence is actually the study of computers or devices that can show intelligent behavior just like humans. And I'm sure you guys had some great discussion about this and came up with something similar. So this relates a lot actually to what we're going to be talking with you guys about today, which I said in the beginning is brain computer interfaces, or BCI for short. And as you can see on the slide here, this is how BCI is defined. It's pretty much a system that allows for the brain to send messages to a device, which tells it to perform some external activity. And one fun fact about this is that the first ever research on BCI was done at UCLA. So now we're just going to show you a video that depicts what BCI can do.
In this paper, two people with tetraplegia, that is, two people who were unable to move their arms or their legs in any functionally useful way, were able to control a prosthetic or a robotic arm simply by thinking about the movement of their own paralyzed hand. And they did that using the investigational BrainGate neural interface system. So they thought about using their own arm and hand as though they were reaching out themselves with their own limb, and the robotic arm moved much the way their own arm would have moved. One of the long-standing questions, not only in neuroscience but in neurorehabilitation, is whether the cells in the motor cortex and other parts of the brain, whether they continue to function the same way years after that original injury.
It is possible for people to use their thoughts to control devices, either a computer or a robotic arm.
That's pretty cool, huh? So you can see it's pretty amazing what the applications of BCI are. So now we'll actually talk a bit about the history of it, and we'll start off by talking about something called brainstorms. So brainstorms are defined by one of the pioneers in the field of BCI, Miguel Nicolelis, as electrical storms of hundreds of brain cells firing consecutively. And you can see in the bottom left corner, this animation is showing some brain cells in action, and you can see that there's a lot going on. And so if these brainstorms are heard with a loudspeaker connected to electrodes, which are these little discs that when attached to the head can detect electrical signals that are coming from the brain. And so if you were to hear these brainstorms using electrodes and a speaker, it would sound like you're making popcorn while listening to a badly tuned radio station. So really, this just shows us how active the brain is at all times and makes us wonder if we can figure out what's going on inside the brain, and if so, what it's really trying to do. And we are actually able to do this, so we'll go on right now to talk a little bit about how this can be done. So one way for us to tell what's going on in the brain in the brain is by using sensors, which are basically electrodes that can measure the electrical activity of neurons firing in the brain. And on the left here, this is what they look like when they're attached to somebody's head. And you can see that there's a lot of them, and they're spread out all across this person's head to fully detect as many signals as possible from all the different regions of the brain. And so this measured activity detected by the sensors, which is basically a signal telling your hand to move, or any part of your body to perform an action. Um, it can then be converted to a digital signal or command that is sent to a computer, which interprets the signal. And the signal can then be transferred to a device like a prosthetic arm, which performs the motion of moving your hand or grabbing onto something like the little football there in the picture, whatever the signal is that's coming from your brain. So the first BCI that was ever done was developed by the pioneer of BCI, who I mentioned earlier, Miguel Nicolelis, back in the early 2000s. So Nicolelis observed in his research lab that a trained monkey named Aurora could chase a moving dot with a cursor on a computer screen by moving a joystick in the correct direction, kind of like chasing someone in a video game. And every time Aurora hit the target, she got a juice reward. So through a bunch of trials, she kept on doing this, and she'd keep on chasing the dot, and she'd keep getting some juice in return. So while she was doing this, Nicolelis decided to use sensors to measure the activity of Aurora's brain, the brainstorms, as he called it, and had them linked to a robotic arm that learned to mimic the movement of Aurora's arm. And eventually, Aurora was able to control this extra arm by just thinking about it. And without moving her arm at all, she could keep controlling the joystick through the robotic arm and hit the target to get another juice reward. So now we'll talk about even more work done with BCIs. And after already seeing some of what you can do with BCIs, I'll ask you all more of a theoretical question. And that is, do you think it's possible for our brains to send messages to each other without us even having to talk to each other? So I'll ask you to pause right here to think about it and discuss if you think it's possible. And if so, give just a brief explanation of how this could maybe be done. Again, I'm sure you guys had some great discussion. And so, yeah, this is possible. Researchers at the University of Washington were able to show that if two people were sitting in two different buildings on the college campus, and one of them had sensors attached to their head that tracked brain activity and was linked to a computer that could send the signals it received from the brain over the web, the other person could receive those signals and perform whatever action the person with the sensors attached to their head thought of. And you can see the person on the right in this image here is wearing this swim cap and has this weird looking magnetic coil placed on top of their head, which actually is able to control their hand movements. And so with this setup, they're actually able to play this computer game where they had to defend a city by firing a cannon and intercepting rockets launched by a pirate ship. So the person on the left is watching the screen and can think about firing a cannon in the game. And the signal can then be transmitted through the web to the receiver, whose hand moves automatically to fire the cannon.
Okay, so now we're going to move on to prosthetics and how they connect to brain-computer interfaces. So first of all, a prosthetic is an artificial limb that replaces an amputated or damaged limb. On the other hand, a neuroprosthetic is, I guess, kind of like an artificial brain. It uses artificial devices to replace the function of damaged brain regions or even sensory organs, and they can connect to really any part of the nervous system. And so an example of a neuroprosthetic is a cochlear implant, which sort of acts as an internal hearing aid, or a retinal implant to improve the vision. On the other hand, BCI is entirely restricted to direct connections to the brain. So that means they cannot connect to sensory organs. And so if you are trying to connect BCI and neuroprosthetics, in reality, BCI is a more specific example of a neuroprosthetic. All right, so now that you've learned some of the things that BCI has been used for until now, I want you to think, if you could use BCI to do whatever you wanted in the world, what would you want to do? So take ahead or go ahead and take a few minutes and draw something on a paper or a notepad and really be creative with it. Okay, so now that we're back, I'm sure that you all had some great ideas, and now we can continue on with some types of BCI. All right, so firstly, we have non-invasive BCI. So EEGs, or electroencephalographies. EEG is a test that measures electrical activity in our brains using electrodes attached to the head. And you might remember what electrodes are from earlier in the presentation. Electrodes are flat metal discs that are fitted in a cap, as you can see in the picture there, and that is then put onto the subject's head. And the wires from the electrodes are connected to a computer. And so EEGs usually show results that are seen as wavy lines that represent the electrical activity of the brain. And abnormalities in the EEG waves can be used to diagnose disorders such as OCD. Next, we have MRIs, or magnetic resonance imaging. So an MRI uses info from the location of water molecules in our body to produce an image of the inside of our bodies. And they can be used to diagnose tumors, fluid buildup, or tangles seen in Alzheimer's affected brains, and just other degeneration of brain regions that can cause various diseases. Now we move on to invasive BCIs. So, firstly, invasive BCI can be used to attack vision. So the two types of implants that we're going to focus on are artificial silicon retinas and brain implants. Artificial silicon retinas, usually you insert devices that contain about 3,500 solar cells that convert light into electrical impulses in the retina. And this sort of mimics cells in the eye that usually do this conversion. And then brain implants carry a visual signal from a camera directly into the brain via electrodes that are in contact with the visual cortex at the backside of the head. And you can see in the image on the right, the visual cortex is identified there at the back right of the brain. Next, BCI can also be used for movement. So as seen in the example from earlier with the monkey, communication from the brain to the robotic arm bypasses the regular motor system for movement. And this can be used to restore function in people disabled by neuromuscular diseases like cerebral palsy, stroke, spinal cord injuries, or locked-in syndrome, which causes paralysis. And locked-in syndrome is like a state of coma. No one really knows if the person can feel or think anything because their ability to move and speak is completely lost. And BCIs are amazing because they can allow these individuals to communicate or operate devices that might help them express or move certain things. And these motor BCIs are invasive because they're implanted into the brain surgically. And so they provide a high quality signal, but they may also lead to tissue damage over time. Okay, Stephen Hawking is a famous physicist who was paralyzed by ALS. Now, I don't know if any of you remember the ice bucket challenge from earlier last decade, but the ice bucket challenge was actually originally created as a way to fundraise for patients who have ALS. And so iBrain technology was a small black headband with a very light device the size of a matchbox that was created to allow Hawking to communicate by just thinking. It's a portable neural device that could monitor and diagnose other disorders like autism or depression as well. And so that could potentially replace even the EEGs that I mentioned earlier. And Hawking used a computer-based communication system, which included a tablet computer mounted on his wheelchair, as you can see in the image at the bottom. And he argued that the BCIs he had tried before were not as effective as this device, which actually detected his cheek movement. A cursor automatically scanned the keyboard, and his cheek movement guided the cursor which keys to stop at, which then allowed him to make a sentence which was digitally analyzed and processed to produce speech. And Stephen Hawking is a key figure in the history of BCI. And so we just hope that you could extract some knowledge and context on BCI based on this little case study. Anyway, thank you so much for watching. We hope you enjoyed the video and learned a lot. If you want to access more information about our club, feel free to visit interacton at ucla.org. And if you'd like to learn more from some of our videos on YouTube, our YouTube channel link will be in the description. Thank you.